These notes are going to get you through your assignment. They're similar to the PDF that I did, the video I did earlier, but we present things in a little different manner. And this time there are drawings. Now I do want you to look at the Venn diagram we have at the top left corner. It shows you where everything fits. It says classifying quadrilaterals. And you'll see the quadrilaterals, the little black things, are in the circle, quadrilaterals. Everything in there is a four-sided figure, is a quadrilateral. But notice a smaller group of quadrilaterals are the parallelograms. So all parallelograms are quadrilaterals, but not all quadrilaterals are parallelograms. Not every four-sided figure meets the conditions to be a parallelogram, but every parallelogram has four sides. Now we're going to go to smaller subsets. The red ones are rectangles. Every rectangle is a parallelogram, and is a quadrilateral. You can count the sides on the rectangle. There's a picture right there. The green ones are rhombi. Every rhombus is a parallelogram and a quadrilateral. Now squares are the coolest of all. Squares are rectangles and rhombi, as well as parallelograms and quadrilaterals. As the groups get smaller, there are more conditions for them, and we'll get to that. So first, let's do number one, the quadrilateral. Any four-sided figure. Any four-sided figure. Now, let's look at number two, parallelogram. And I'm going to use my colors. First, opposite sides are parallel. And we're going to do parallel. You're going to see it with a triangle. The triangle or the arrowhead on the line means parallel. Opposite sides are parallel. Opposite sides are also congruent. So this side is congruent to this side, and this side is congruent to this side. I use different marks because the arrowheads mean parallel lines, and the single line is a congruency marker. What else do we know? We know that opposite angles are congruent. Those angles are congruent, and those angles are congruent. So every parallelogram has those properties, but not every quadrilateral has those properties. Now we're going to talk about a rectangle. Change up the colors a little bit. First, opposite sides are parallel. That doesn't change. Pretty little arrowhead. Okay, those are all parallel. Opposite sides are also congruent. Okay, that hasn't changed either, has it? So far, the qualifications of a rectangle are also those of a parallelogram. But here's the different one. All the angles are right angles. That, and that. That's the difference between a rectangle and any other parallelogram. All the angles are right angles. Now let's talk about a rhombus, because remember, if you look back up at our drawing, rectangles are in red, rhombi are in green. So we're going from the big circle, which is quadrilaterals, circle number one. Then we're going to number two, parallelograms. Then we're going to 3A. Then we're going to do 3B, which is rhombi. Now in a rhombus, opposite sides, I'm just going to start in order, are parallel. Just like in every parallelogram, because a rhombus is a parallelogram. All sides are congruent. So notice I'm using one single congruency marker because all four sides are the same length. If you go back to the rectangle, you see that I had my left and right sides as one length and my top and bottom as a different length. The last part are opposite angles are, well, we know that. That doesn't change. Congruent. This angle is congruent to this angle, and these opposite angles are congruent. Now let's talk square. What do you think is going to be different? And what do you think is going to be the same? Opposite sides. They're still going to be parallel. They have to be because a square is a parallelogram. All sides are congruent because a square is also a rhombus. And all the angles are congruent. There we go. Let's go to the next page. Now, trapezoids are they're slightly different. They are still quadrilaterals, but they have something a little special. One set of opposite sides is parallel. Can you guess which one? Top and bottom or left and right? Top. In this case, top and bottom. You can see those are parallel. Now we're going to do something that you're going to see on Alex. You have to see for A, B, and C. You have to determine which figure A, B, and or C fits. So let's do it in red. A. Which figures are squares? Now a square has to have all four sides the same size and all four angles are congruent. Well, only figure A has all four angles congruent. Figure C, nope. Figure B, nope. Figure B has all four angles congruent, but the sides are not, all four sides are not congruent. So only figure A fits that one. Now, which figures are parallelograms? Well, we know A is a square, so therefore A is a parallelogram. Take a look at figure B. All four angles are 90 degrees. That's a rectangle. Opposite sides are congruent. That's a rectangle. Oh, figure B counts. Now figure C. We know opposite sides are congruent. So actually, figure C is a parallelogram. The only way opposite sides can be congruent is if it is a parallelogram. Last one. Which figures are rectangles? Well, figure B is the obvious one, right? But remember, all squares are rectangles. But not all rectangles are squares. We're going to, again, do some more with this, looking at these figures in different ways. So you know what, you've got a picture of a square in your head. Select everything that applies to a square. Does a square have two pairs of parallel sides? It does. So therefore, it doesn't have only one pair of parallel sides. In a square, are all sides congruent? Yes, they are. In a square, does a square have 4 right angles? Yes, it does. Now let's look at a parallelogram. Does it have 2 pairs of parallel sides? Well, if you're not sure, go back to the last page. A parallelogram. Number 2, opposite sides are parallel. So yes, it does have 2 pairs of parallel sides. Therefore, it does not have only one. Does every parallelogram have congruent sides? No. Because a rectangle doesn't have all 4 sides congruent, but a rectangle is a parallelogram. Does every parallelogram have 4 right angles? No. A rhombus is a parallelogram, but it doesn't necessarily have 4 right angles. So the only thing that applies in this chart for parallelograms is it has 2 pairs of parallel lines. Now let's think about a trapezoid, top of the page. Does it have 2 pairs of parallel sides? It does not, but it does have only one. All sides are not congruent in a trapezoid, and it does not have 4 right angles. You may want to stop the notes here, go back to the first page, look at the diagram, and look at our requirements, both on this first page and on the other video. Now we're going to do some more examining. And some of this sounds like repetition, I know, but the more you hear it and the more you write it, the more you'll remember it. So true or false? Let's pick yellow, I like it. We're going to use this Venn diagram, and you're going to see what's true or what's false. Is every square a parallelogram? Well, squares are inside the parallelogram, so yes, true. Every quadrilateral is a rectangle. Is the quadrilateral circle inside the rectangle circle? It is not. We know not every quadrilateral is a rectangle. That is false. Is every rhombus a parallelogram? Well, this whole circle of rhombi, is inside the parallelograms, so every rhombus is a parallelogram. And every rhombus with 4 right angles is a square. Ooh, gotta think about that. Well, every rhombus has 4 congruent sides. That's a requirement. A square has 4 congruent sides. And a square has 4 right angles. So yes, every rhombus with 4 right angles is a square. All right, so now we're going to look at diagonals. Various properties of diagonals. We talked a little bit about it on the chart on the first video. Now we have, again, drawings and figures to go with it. So I'm going to draw the diagonals, and then I'm going to mark everything up. So let's go. In a parallelogram, all diagonals bisect each other. So that bisects each other, which means this part is congruent to this part, and this half is congruent to this half. The same goes for a rectangle. Don't comment on my drawing. You know I can't. A rhombus. And a square. This is the second time I'm doing these notes. My first notes looked better. Okay? The diagonals bisect each other. Now, diagonals are congruent. Well, that only happens in a rectangle and a square. There we go. Now I'm going to label these because I want you to really see this. A, B, C, D. And W, X, Y, Z. So in the rectangle, we know AC is congruent, that's a lousy congruency, to BD. And WZ is congruent to XY. But also, remember, their diagonals bisect each other, don't they? So that means, I'm going to work with the big rectangle first. That means, let's call this P. That's the center point, P. That means AP is congruent to CP. And BP is congruent to DP. And since AC is congruent to BD, what that means is all four pieces, AP, BP, CP, and DP, are congruent to each other. Same thing works in the square. I'm just not going to do it again. Okay, now, in a rhombus and a square, diagonals are perpendicular. So they form right angles. Now, they still bisect each other. That property has not gone away. Let me fix my square. There we go. So if you look at the congruency markers, let's start at the top. Diagonals bisect each other. So in a parallelogram, one diagonal is cut in half by the other. So each small piece is congruent to the opposite side. See, in the parallelogram, rectangle, rhombus, and square. In a rectangle and square, the diagonals are congruent. That means when they bisect each other, they create four congruent short segments. Now in a rhombus and a square, the diagonals create right angles. They are perpendicular, but they still bisect each other. So that means, this is A, B, C, D. That means AC is still congruent to BD. And we'll make that Q. And AQ is congruent to CQ. And I cannot say, and I apologize, I cannot say the statement I said up there. I don't know why I put it there. Because they are not congruent. Go, Mrs. Gates. But BQ is congruent to DQ. So each half is congruent to the matching half, but they are not congruent, but the big diagonals are not congruent to each other. Now we're going to go to the last piece, the last one. Diagonals bisect angles. Drawing again. This is going to come in handy when we start applying these properties to find the measurements of missing angles. So in a rhombus, we still have this right angle, same in a square. But now, let's see, let's label these. A, B, C, and D. And that's Z. This angle is congruent to this angle. And this angle is congruent to this angle because they are bisected. So what we know is angle B is congruent to angle D. Opposite angles of a parallelogram are congruent. A rhombus is a parallelogram, therefore opposite angles of a rhombus are congruent. Well, we can break it down. We can also say angle ZBC is congruent to angle ZBA. That is this one. Because Angle B is bisected by diagonal BD. I'm throwing so many letters at you, I know. But everything is written down here so you can stop, re-listen, and follow along as you do it on your papers. All right, let's do 2 more things. And these are not so much cheat sheets, but they're kind of simple ways to know. If one pair of sides of a quadrilateral is parallel and congruent, then it's a parallelogram. So if these are parallel and congruent, then it's a parallelogram. I don't need to know anything else. That statement alone tells me it's a parallelogram. Now this one. Ooh, this is kind of interesting. Here, you have to, number 1, erase my mess. You need to be able to know about alternate interior angles. You've got to remember this. So what we do is you draw a transversal. Diagonal is a transversal. And if this angle is congruent to this angle, they're alternate interior angles. And that means it's a parallelogram. Well, let's look at this one. We can draw it in a different color. Let's do the transversal this way. And this angle is congruent to this angle. That is also a parallelogram because the lines, the sides are parallel. Let's write this down. Sides are parallel lines. That's a symbol for parallel lines. And diagonal is transversal. Okay? And that is page 3. Now on this page, you see another question, another thing that looks like Alex. We take it straight out of there. So you're going to select any and all of the categories that fit the picture. Sometimes you're going to know more than you do know. So first of all, is figure RST a quadrilateral? Well, yeah, it has 4 sides. It's a quadrilateral. Now in this, we don't know any side measures, but we know opposite angles are congruent. That's a parallelogram. Do we know if the angles are 90 degrees? We do not. So we do not know if it's a rectangle. So we have to leave that blank. We don't know. Let's look at WYXV. Yeah, 4 sides, quadrilateral. Is it a parallelogram? Well, let's look at the marks. We have 2 arrows here. Those sides are parallel. These sides are parallel. And look, well, first, opposite sides are parallel. That's a parallelogram. Now you've got the diagonal is bisecting each other, and all 4 diagonals, all 4 pieces are congruent. That's a rectangle. All 4 pieces are congruent. If you go back to the previous page of notes with the list of diagonals, properties of diagonals, that'll help. Next one. 4 sides, it's quadrilateral. You better get that question right. If you can't count to 4, there's a problem. Is it a parallelogram? Well, let's think. All 4 angles are congruent. If all 4 angles are congruent, yes, it's a parallelogram. And you know what? It's a rectangle. I'm going to give you a hint. Number degrees in quadrilateral. Anybody? 360. So if all 4 angles are congruent, then all 4 angles are 90 degrees. Ooh, gotcha. All right, next application. This is the last one you're doing with this lesson. We are given the information below. The information we are given is in the figure. So let's take a look at figure KLNM. We have diagonals. We don't know anything about the sides. There's nothing about the sides. Now, if you look at the diagonals, They are not bisected because NO is not congruent to KO. And LO is not congruent to MO. So it is not necessarily a parallelogram. Diagonals not bisected. It might be, but we do not know that. That's why we say not necessarily. You learned that in Unit 3. Don't have enough information. Okay, let's look at PQSR. Well, the sides are congruent and parallel, which means it's a parallelogram. We learned that on the last page. Now here we have one pair parallel sides. And look, there's the transversal, and we have alternate interior angles congruent. It is a parallel because BC is transversal. Last figure. Opposite angles are congruent, and that is a parallelogram. So there you go. That is day 4. Excuse me, that is page 4 of day